Right. Page number 17, there you have a practical, the same practical, but we have discussed there. Right. Mm, I mean, we did this practical at the first page. So for your reference, again, you can put the page number as well, the same practical. They are asking. By analyzing the results of this practical, right, propanone and iodine practical, it suggests that the rate depends on concentration of propanone and the concentration of H plus, right? Concentration of propanone and concentration of H plus, right? So this is the suggested mechanism. So let's draw the suggested mechanism. Sometimes you may ask to draw this, right? Okay. We'll start like this. Our tertiary halogen alkanes we finished. That's it. Okay. Now the topic is propanone and iodine reaction. No? Okay. They are. First write the main equation. First write this equation, main equation. Please copy the main equation. Iodine plus propanone. Right, Harry. This is the main equation. Then this is the rate equation. Copy the rate equation as well there. Now, main equation, the reactants are iodine and propanone. H plus is the catalyst. But in the rate equation, iodine is not there, but H plus is there. Therefore, in the mechanism, right, H plus and propanone should be there in the slower step, not the iodine. Therefore, minimum number of steps for this reaction is 2. Why? Because iodine is not involving in the rate determining step. Sometimes you may ask that kind of question. Right. Identify the minimum number of steps. Now is that clear? Clear? Then here, the main equation says iodine and propanone and H plus. H plus is the catalyst anyway for the reaction. But the rate equation has only propanone and H plus. Iodine is not there. Therefore, definitely iodine should be collide with these reactants, no? Right? Now, but the slower step you have propanone and iodine only, propanone and H plus only. Right? Therefore, there should be another step that iodine has to come and react. Therefore, minimum number of steps will be 2. That's the hurry. So let's now here it's difficult to yourself to determine the mechanism, but if you have the ability to think like something blah blah blah, you can draw this, right? And look at this. they have just combined H plus and propanol. In the second stage, still this is fast, but the second one is slow. This OH minus and make one H plus from this carbon to remove. So still in the first two stages, propanone and H plus one. Okay, copy these two. H plus and propanone will be react to form this molecule. From this molecule, one of hydrogen in the carbon leaves. That's no problem. That's it. Yeah. Good work. Right. Okay, done. Next one then. Next step, final step, where you can see the iodine. Right. This first. So where the iodine is there, the reaction become fast. Because and only one slow step. Very fast. First step is fast. Second step is slow. Last one is fast. Okay. It's not there. You have right. Testing the mechanism. Right. Done. So we have to check the mechanism whether it's correct or wrong, right? So these are the important part. Now, even though we suggest the mechanism, right, we have to check whether our given mechanism is correct, right? So in the given space, write the topic testing the mechanism, right? And copy this one. We have a proposed mechanism for the reaction that is consistent with the kinetic data obtained from the experiment. Why the mechanism faster with iodine? Because the slower step is already gone. And the other thing is iodine is not involving in the rate determining step. This is not the same as it's saying the mechanism is the correct one. Indeed, the most likely one. We now need to carry the further experiment to confirm or deny our proposed mechanism. And that's it enough. So 3 techniques. And we have 3 techniques. I'll explain these 3 techniques. Okay. Proposed mechanism may be correct or not correct. Therefore, we have to do further testing to check our proposed mechanism is correct or not. Yes. Right. First technique, you have to use wider concentrations. That means, right, you can use different concentrations of each reactor, right, and check whether it's follow the rate equation. Now, for example, what we have done when finding the order of reaction in the initial rate method, we took concentration of one reactant constant, and you are going to change the other one. That's the mechanism. That's the thing, right? Like us, you can check. Yes. So we are going to determine the mechanism now. Right? Okay. So just write the use a wider range of concentrations. Right. Next one, use instrumental analysis. So while the reaction is taking place, right, you can analyze the concentration of each reactor, right? Okay. Yeah. You are going to let the reaction to happen. Then you have to use physical methods, not the chemical methods. Instrumental analysis. And you can check whether the intermediate has formed or not. And finally, carrying out the reaction with deuterated propanol. Deuterium is one of the isotope of hydrogen and behaves slightly different to hydrogen, right? Therefore, now in our suggested mechanism, the first step you have a hydrogen involved. So instead of H plus, you can add D plus, or else you can use CH3CO CH3 instead of CH3CO CH3. You can use CD3CO CD3. D stand for deuterium. Deuterium, isotope of hydrogen. Right. Okay. Instead of H, they are writing D. Purpose of identification only. Right. So that we can check whether the D is there or not. D has removed them. In our proposed mechanism, right? Here in the second step, one of the hydrogen is goes no. If D is here, you can clearly see that D goes out. Okay. You can analyze the deuterium, presence of deuterium. Yes. We want to make a CD bond. ACD name a CD bond, carbon deuterium bond. Copy that one as well. That's what we are going to do. Slower step is the ready to step. Can you mean what is in the slow step, what is in the fast step? Most probably we can finish the lesson today and we have to draw another type of graph. Homework also there. Hi, homework. Did? Huh? Couldn't do. Some. How was that small tip? Just 42 pages one? Oh. How many? Now in the mechanism, we can check whether the proposed mechanism is correct or wrong by using these methods. For that, again, we are going to check the rate equation, but is in the slow step. For that, you can use different concentrations. As I told you, you are keeping one constant, changing the other one, right? It was then instrumental analysis. We are going to check analyze the intermediate product that form. Or else you can use hydrogen, isotope of hydrogen instead of hydrogen. And you can check whether it's there or not. Finish? Finish writing? Right. Done. Questions. Checkpoint questions. Okay. First, answer the question number 1. No need to write the question. This is page number 18, checkpoint questions. Answer something. Kaushika, can you tell me the answer for the part A? From yesterday itself, that's an issue in my Zoom. I don't know what's wrong there. So the meeting will be disconnected in 10 minutes. And you had to join again. Sorry for that. I'll try my best to fix it. Which of the two mechanisms consists in the rate equation? Mechanism 1 or mechanism 2? If the meeting disconnected, if they are not going to join again, that means they are sleeping. Okay. Step 2 is the rate determining step. Why? Because in the rate equation, hydrogen is not involved. Right? Yeah. Mechanism 1, in mechanism 1, hydrogen is there in the first step. Right? So Cn is the second step. Therefore, this is the second step will be the slower step. If the second step going to be the slower step, all the reactants up the second step we have to add. Therefore, all three are in the mechanism. That's why it's wrong. So the mechanism 2 is the consist with the rate equation because, right? Rate equation says only CH3CHO and Cn minus is there in the slower step. Fast, yes. Right. Rate determining step again is the first step. Clear? Good. Yes. Okay. And I'll make it continuously happen. To disconnect and you have to join again activity. Avoid sleeping during the class. Okay. Second one. Question number 2. Is the mechanism is consistent with the rate equation? Yes or no? Yes. 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 Okay. Explanation is important. ඒක තමයි පුරුදු වෙන්න ඕනේ. Okay. Rukaya, what do you think? Is the mechanism is consistent with the rate equation or not? I'll explain the question one again later. In the classic. Pranav, is the proposed mechanism is consist with the rate equation or not? Pranav. Kaushika, is this consist with the rate equation only? Ah, yes. Very good. Natasha, what do you think? Is this consistent with the rate equation or not, the mechanism? Now the rate equation says 1 hydrogen and 2 NO should be there in the slower step. According to the mechanism, second step is the slower step. Therefore, all the reactants up to the slower step should be there in the rate determining step. That's the explanation. Therefore, when you're going to add these two, this will be cancelled out. So you can see 2NO and 1H2, and it is consist with the rate equation. Okay. So answer, I'll repeat. So in the rate equation, it says 1 hydrogen atom and 2 NO. 2 NO molecules should be there in the rate determining step, right? In the proposed mechanism, step 2 is the slower step. Therefore, it shows that 2 NO and 1 H2 molecule will be there up to the slower step. Therefore, proposed mechanism is consists with the rate equation. Mates, just not listening now, you have to practice how to write the answer. It was explain. Sorry. You should have that practice. Very good. Very good. Okay, for your benefit, I'll share the answer script as well, so you can quickly copy now, rather than thinking. This part only. Here is the answer. But always try to write the answer in your words. Huh? डॉक्टर्स लागे बोले मट्टी ना किलोमीटर तुम्हारा Finish copying. Here we go. Okay. I'll show the answer for the first one as well. Finish writing. Still writing this. Right. The first one then. Answer for the first one. Here. Mechanism 2 is consist with the rate equation. It has